Okay, so I'm going to go over the homework, and I might not have written this for all of the classes, so I would suggest that you guys write that down first. So pause the video, freeze it, and then write this down. So the number one is what type of transformation. You need to write that, which is, there's four of them. There's translation, reflection, rotation, and dilation. And then tell whether it's rigid or non-rigid, and then tell whether it's congruent or similar. So just as a quick review, let me pull out the interactive notebook. And hold on. So what we talked about was in class that transformations, there's two types. There's rigid transformations and non-rigid. Now if you look up the word rigid, it's kind of like strict. Like rigid means like immovable, in the sense that there's nothing that changes about it except, in this case, its position. So for example, a translation will stay the exact same shape and size from pre-image to image, so it's a rigid transformation. A reflection will stay exactly the same shape and same size, and therefore it's going to be a rigid transformation. And then rotation, also when you turn it, it keeps its shape, it keeps its size, so it's going to be a rigid transformation. And the thing about rigid transformations is that all of their pre-images and images are congruent to each other. They are the same size and shape of each other. Whereas non-rigid, there's only one transformation that, excuse me, is non-rigid, and it's the dilation. It's the same shape but has a different size. And because of that, it makes the pre-image and the image similar to one another. Okay, so and dilations are the only ones that have similar pre-images and images. So let's talk about this. So in class, I think we got to various places in class today, but just as a quick review for number one, this is a translation. So we took our patty paper and we put it on top. We traced the pre-image. Remember, we know this is the pre-image and this is the image because the image has the primes. That means the translation went from here, began here, and ended up here, not the other way around. So we traced this triangle and we slid it down diagonally until it reached the other triangle. So there was that. And then, because it's a translation, let me go back to the notebook. Because it's a translation, the translation will be a rigid transformation. It's in this category. And therefore, its pre-image and image are congruent. So therefore, we wrote it's rigid and the pre-image and image are congruent. Number two, we knew it was a rotation. Well, some of you thought maybe it was possibly reflection. The problem with that is that if you try to reflect, you would have to reflect over a line, and we don't have that. So we would have, well, we do have a line, but not one that will cause us to reflect. We can't reflect over the x-axis and get that image. Can't reflect over the y-axis and get that image. So it looks like this was a turn. So if you take this, pin your pencil down on the patty paper, and then turn the patty paper, you'll see that it rotates, and then it should end up on the image. Okay, the I corresponds with I, G with G prime, F with F prime, and I guess this was H. H with H prime, I with I prime. And remember, you can go clockwise. So let's say we start here, and you go in the direction of a normal clock, which goes this way. Then you can end up on the image, or you can start and then go counterclockwise. Okay, go in the other direction, and you can also get it to it as well. Okay, so now let's go to number three. We also, some of us got to number four. I'll get to that in a second. So let's try number three. Now I can tell that this is the pre-image because it is has no primes, whereas this one has an image and it has primes. So it means it went from here to here. Now I'm going to show you why it's not a reflection. Let me grab a new piece here. So let's go to the pre-image, all right, and we're going to use, or we're going to write L, M, N, and K. Okay, so let's say some of you guys thought it's a reflection, you know, maybe it reflected over the x-axis. So I'm going to line up the x-axis. I will actually trace that out. So if you see it to the side, you can see, oh, I have my shape L, M, N, K, and then I also have the line of reflection if it truly is a reflection. So if it is, I should be able to flip this over, line up the line, and they will match up perfectly. But they don't. So it can't be a reflection, okay, because if it was, it should end up exactly here, okay, right above. From here to here, you see the K goes to K prime, L to L prime, M to M prime, and then N to N prime. So this can't be a reflection because they don't match up. Well, it can't be a translation because if I were to ignore this line now, since we know it's not a reflection anymore, okay, so that's not a reflection now, so let's try translation. Do you think it's a translation? Well, remember, translations, all you do is slide down. You don't flip it. So slide down or up, or, okay, now no matter what I do when I slide it, it doesn't match up. So it can't be a translation. And it's definitely not a dilation because the size didn't change. So it looks like rotation is our bet. So again, I told you in class that your center rotation will always be here at the origin. I'm going to make the lead go away for my mechanical pencil, so I can't write with it, but I can use it to pin this origin down. And now let's turn it. So one moment, please. Okay, so I can go clockwise, and it'll take me a while to get there. Okay, so let me hold it down. Clockwise, 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 but I do get there, and it matches up perfectly, okay? Or I can go counterclockwise, which is the opposite direction. And I start here, and I go backwards, which is called counterclockwise, and I'll end up there even faster. So what's our answer here? What type of transformation has taken place from the pre-image to the image? Okay, went from here to here, or you can go all the way around this way as well. But it was a circular motion. And which transformation is circular in motion? Rotation. I'm going to write 1 based on what I wrote here. It's a type. What's the type of transformation? It's a rotation. And then number 2 is a rotation rigid or a non-rigid transformation. It's a rigid transformation. And then is a rigid transformation, are they going to create congruent figures or similar figures? Congruent, they're the same shape and size. In fact, when I match it up here and then I turn and match it up here, the shape didn't change, the size didn't change, so that means they're congruent. And remember, coming back here, rotations in this category, rigid, which means this it's the same shape, same size. The pre-image and its image are congruent. Okay. Number 4, I don't know if we got to this in every class, so I'm going to reuse one of my Patty papers. And this is the pre-image, this triangle up here, because there's no prime on it. So I have F, E, and G. And then let's try translating. So let's say I slide down. Nope, they don't match up. The G's match up, but the F and the E do not match up, so it can't be that. So it's not a translation. Let's try a rotation. So let's say I trace this, and like I said, the origin is right here. And let's say I put my pencil on it like this, and I turn it. So if I turn, nope, the F's end up being matched up, but then the E and the G are completely off. You should not be able to see the other triangle here. They should have matched up perfectly. So it's not a rotation, okay? So it's not a dilation because it's the same shape and size. So what happened? It must be a reflection. So let's draw the line. You'll need to draw the line where it reflected over. And for now, we're always going to use the x-axis or the y-axis or this other line that I will teach you about. But right here, it looks like the mirror is right here. So we're going to go with that. And then I'm going to literally take the paper and flip it, line up the x-axis, and then what do you know? The E goes to E prime, the F goes to F prime, and the G goes to G prime, flipping over, okay, the x-axis. So this was a reflection. And the reflection, if you look at reflection, 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 reflection Reflections are always rigid transformations which make their pre-image and image congruent. So there's our answer there. Number 5. Now 5, I love this question, and I hope you will like it too, because this is the type of question the county likes to ask, and also the GMAS likes to ask. So I really love this question. So this means you have to pay attention to the letters. Okay, so let's try this. Okay, so this is my pre-image because there's no primes here. This is my image because there are primes there. Okay, so that means we started here and then we ended up here. So let's say we translate. So I'm going to trace my original, and I take X and then Y and then the W. Okay, then if I translate, here's the thing. Slide. Hey, they match. However, so let's look at this. The W, I'm going to look at the letter over here. Hey, W and W prime, they match up. Problem is, the X and V prime, they don't match up. And the Y and this X prime, they don't match up either. So something's not right. Okay, well, so was I supposed to rotate it? So let's try rotating. So it's not translation. So let's try rotating. You need the center. I'm going to take the lead out of my pencil. And then, like I said, guys, do this video again, or do this problem again without my help. So let's say I rotate as far as I can to match it up. Man, it doesn't match up. It doesn't match up at all. Maybe these points match up, but X and X prime, but Y and W, they don't match up with their Y prime and W prime. So no matter what I do, the rotation is actually not going to work. The translation didn't work. It's definitely not a dilation because they're exactly the same shape and size. So it must be reflection. Let's take a look at reflection. If you're going to do reflection, then you ignore this because that was for rotation only. And it looks like this line here is right between these two figures, so that might be our line of reflection. So I'm going to use that. Now when I flip it, okay, I need to make sure this lines up and these match. Letter to letter, okay, they should match. So I'm going to take my paper and I'm going to flip it. I'm going to line up the line of reflection and I'm going to match it with this. Now here's the cool thing. This W, if I flip it up, matches with W prime. This Y matches with, oh, it's a V. Ugh. Okay, I'm sorry about that. But, okay, so let's say this is a, hold on, V. I've got to be careful about this. Sorry, guys. So this V, when I flip it over, okay, matches with this V prime. And then this X matches with its same letter but with the prime. This is the correct transformation to take place. So it's not a translation, okay? So this is where a lot of students do not pay attention to the letters and they just say, oh, it slid over. It didn't slide over. It actually reflected over the y-axis. So this is a reflection. And all reflections are rigid. The only thing that's non-rigid is dilation. So rigid and all rigid transformations have their pre-image and their image being congruent. Same shape, same size. Alright, lastly, number 6. Okay, this is quite obviously not a rigid transformation. So this is going to have to be dilation because it did keep its shape. It looks like a right angle here. It's a right triangle. And we'll talk about this in class, but yeah, we'll talk more about it. It's a dilation. And what do we know about dilations? They're non-rigid because they change size. So that means this pre-image and image are not the same size and shape, but they are similar. Or they're not the same size, but they're the same shape, which makes the pre-image, which is here, and the image similar. Now guys, don't think that that's enough, that you are just copying the answers try going back through and seeing if you could do it again without my explanation, or you're able to explain it to someone. It's not enough to just watch the videos and copy down the work, okay? It will show up. If you don't really know what you're doing, when we quiz you or test you, then it'll come up on there. So really try your best to do your homework.